Assalamualaikum warahmatullahi wabarakatuh. Very good day. We are continue our class, our lecture on chapter number 7. The title is rock testing. Okay. Rock testing is part of the rock mechanics. It is a field on the applied science, but now is recognized as an engineering field in last 40 years ago. And then this we study the rock mechanic. We do this rock testing to find the properties of rocks and to understand the behavior of rocks when we load that rocks under loading. So our discussion is based on the properties of rocks and behavior when the rock under loading. So for definition of rock is a mixture of the minerals, one or more minerals, and for soil is uncemented and normally is weak, where the void space is normally filled by water or air. In terms of strength, the boundaries between soil and rock is 1 megapascal in compressive strength. So the other properties that can be differentiate between soil and rock, which is density. Normally the density in rock is higher than soil. For example, granite is density 2,600 kilogram per meter cube, whereas the soil, for example, weathered product of soil grade 6, soil 1,700 kilogram per meter cube, sometimes drop to 1,600 kilogram per meter cubes. In terms of seismic velocity, normally in rocks is quite high. In granite, normally velocity in compressive wave around 5,000 between 3,000 above 3,000 meter per second, but in soil normally is less than 1,000 meter per second. Young modulus for soil normally is higher than the rocks, as well as Poisson ratio. So young modulus is high. The rock is higher Poisson ratio compared to soils. For Poisson ratio, normally soil is higher value compared to these rocks, and porosity in soil is higher. So the important scope in rock mechanics is we are measure and monitoring the behavior of the rock properties, discontinuity in rocks by using specific testing procedure, instrumentation, whether we conducted in laboratory or in situ, the field. So we are determining the rock behavior, and for example, shear or compressive strength. We are look on the failure modes. Also, we look on the elastic modulus, whether Young modulus, shear modulus, or Poisson ratio. So, and then we are determine the method of excavation or design when we get that the properties of rocks. Also, we can recommend the rock stabilizations for the rocks based on that value, the response of rock to the loading. So we start with the rock testing. Rock testing is, as you know, rock is naturally occurring, so it's inhomogeneous, which is heterogeneous, and anisotropic. So in contrast, similar material like concrete is hard like rocks, But this strength normally is, we can design that strength based on their design mix, and normally is more homogeneous compared to rocks. So rock is used in construction as a construction material for filling or reclamation material, or as a shoreline defense, and as a part of engineering structure such as a slope, cut slope, foundation, or underground excavation. So normally we will name this rock because of that is important in design of structure in rock, because since we know the rock's name, we can predict that what's the problems, potential problem to the engineering, or based on the rock name we can able to select which the suitable parameter based on the literature review or previous study. So the rock testing is aimed to measure the behavior of rock under stress. So then that the behavior, which is in terms of rock strength, we can use in the design. So for example, compressive strength, elastic constant, shear strength, all these things we can use for design. So strength of rock, that we need to evaluate in civil engineering, such as shear strength, which is used in slope or underground excavation or foundations. Tensile strength is used in foundation or underground foundation excavations. And parameters of compressive strength we use in slope design, foundation design, or underground excavation. Okay, rock testing. If you rock testing, is can divide into two, which is conducted in laboratory or in situ. The tests are for example, field test is, split bearing test and creep test by using instrumentation. For laboratory tests, for example, compression test, shear test, creep test, fatigue or dynamic loading test. The testing, rock testing, can divide it into two, which is we call that as a indirect or index test. Secondly, we can call as a direct test of strength test. So all these tests is published in ISRM, International Society of Rock Mechanics, in 1982, and that society was produced the standard method for rock testing. Normally, these rock tests using small samples, whereas in the large scale field test, and this when we're using small sample, this result affected the specimen size and the scale of rock mass discontinuity. So based on the sample size and the discontinuity, so we have to evaluate the results and we need to correct the result accordingly. As I said, testing can divide into two: direct test, indirect test, and direct test, strength test or index test. Okay, we start with the index test or indirect test. So this normally not involve sample preparation,